Warm greetings to all. This is the third and the final interim video we are going to submit for our IACDC proposal. And I am Aravinda Prasad, and my teammates are Akash, Mukilan, Pooja, Anirudhi, Nisheta, Swati, and our guide is Dr. V. Rukmani ma'am. Under her guidance, we are doing a project named a Hybrid Energy Generation Tree, and we are from Sri Ramakrishna Engineering College. And our team ID is 1340613. And I'm going to explain the technical presentation with the help of these slides, and these are the contents of the slides. The first one is the research to realization. Under this topic, the first one is the technical detailing, and the second one is a reassembling of the solution for a better understanding of the proposed model. Here, we have proposed an hybrid energy generation system where we have proposed a single structure capable of producing an electricity from both solar and wind simultaneously, instead of coupling an energy from the solar system separately and a wind system separately. Here it has an advantage, like it can even installed on the rooftops or even at the top of the building easily. The second one is the innovation method, like having a different gear ratios for the different location of the users. It is mainly to get a maximum power output of the region, because if for example the user may be from a low wind speed region or maybe from the high wind speed region. Based on the wind speed of this location, the gear ratios will be decided, and it will be implemented on the product. And the third one is the user's experience. We have planned for an ML algorithm for giving some suggestion on the power plants that they have using. And the third one is ideas competitiveness. Yeah, this idea has a competition in the market, because the current trend in the market is the solar cells. But the major disadvantage of the solar cells is like they need a huge space for the installation. Uh, this idea will have a huge competition with with the solar cells, because it will be compact and easily installed even on the top of the buildings when compared to the solar cells. So it will have a tougher competition with the solar cells. And the third one is a feasibility study. Yeah, as I said before, it can be easily transportable, and it can be easily installed on the top of the buildings or even on the rooftops. So it is a feasible product as of from our studies. The next one is the design innovation. Under this, the first one is the intrinsic feature of the product. As I explained before, one of the intrinsic feature is the custom gear issues. Yeah, we have designed a custom gear issues based on the wind speed of the customer's location, and to get the maximum power output. And the second one is the justification of the product with respect to power, performance, and size. Yeah, as of now, it is an prototype and not a product, and it will give a power output of about 750 watt on an average. And its performance also analyzed with the standard one in the market, and its performance is also good, and the size is also an portable and feasible one. Yeah, and the third one is edge technologies. We have used an ANSYS software for analyzing the strength, toughness, and elasticity of the product to get withstand in the market. And the fourth one is the scalability of the product, as we have used the common products which are available in the market and not the rare cases, so it can be scaled to the needs in the market. And the next one is the electronic box we have used. The TI products we have used are a current sensors, the launch pads, step down converters, and a solar charge controllers. Yeah, the first one is the current sensor. We have used it to get a current usage of the customer. And the second one is a launch pad for calculations and the processing of these data. And the third one is a step down converters. We have used it to step down the voltages to store it in a battery. And the fourth one is a solar charge controller, which is a very useful tool for cut off the current and the voltage when the battery is charged. And we are also designed the same for a wind charge controller and some other parts of the non-TI tools. Yeah. The next one is the execution. Under this, the first one is the technical milestones. We have a set of milestones at the starting of the stage. Like will be a four-stage. First one is the design stage. The second one is a proof of concept, and third one is a prototype, and the final one is a product. And we have crossed the design and proof of concept, and we are on a prototype stage. And all the analyses are as expected, and will further move on for a product stage. And the subsequent resolutions are like it will be a safer one on all the circumstances and will not vanish from the market within 1 or 2 years. Like it will be on the market for a long period of time. And the verification and validation is on progress. Like we are testing the product on different circumstances, like a very high wind speed for checking its durability and strength. Like some other processes are being done. And the last one is a behavior trait. Yeah, based on the validation and verification, the pros and the cons of the product will be identified, and will work on these like some, if there is a failure on, and we will work on this to make it as a perfect one. Yeah, the next one is engineering quality and the completeness. Under this, it's a prototype version demonstration. It is a prototype we have developed, and it will have 9 wings. And now it is of our stainless steel, but in the future it will be from solar cells. It may be a flexible type if it is available in the market, and we are working on it, like checking in the market for availability. And the next one is it will have a 9 wings, and it can be either fitted on the buildings, or it can also have a pole for its placement. And now its average weight is about 150 to 170 kgs without a pole, and 200 kg on average with the pole. And it will generate an electricity of about 750 watt hour. And uh, yeah, all the other requirements are also fulfilled, like gear ratios identification for different wind speed. And yeah, it is in verification and validation stage. After this, if any failures occurs, we will working on it for make it as a perfect product, and move for a prototype product development. Yeah, thank you for your patience. Have a nice day.